We want to solve this equation. In order to do that, a good first step is to get a common denominator. And for 2, 4 and 12, 12 would be a good denominator. So for this first term, multiply the bottom by 6, so we need to do the same to the top. Then for this term, if we want that over 12, we'd multiply the bottom by 3, do the same to the top. And this one actually stays the same. Now that we have the same denominator, we can essentially ignore the denominator. So we'll have 6 into 5 take away b is equal to 15 take away 2b plus 5, and this bracket's important. So that's 30 take away 6b is 15 take away 2b take away 5, and tidying, that's 30 take away 6b is 10 take away 2b. So bring the 6b over to this side and we get 30 is equal to 10, add 4b, take away 10 from both sides, 20 equals 4b, and that gives us that b is equal to 5. Now, looking for a common denominator here, 6y would be a good choice. All of these go into 6y. So put this over 6y, multiply the top by 6. If this one becomes 6y, we've multiplied the bottom by 3, do the same to the top. And then the bottom of this gets multiplied by 2, so do the same to the top. And if this one's going over 6y, that needs to be 6y on top. And now we can ignore the denominator. So 6 take away 3 add 2 equals 6y. So that's 5 equals 6y. So y is going to be 5/6. Now, might do some simplification on this first. So let's factorize the bottom here, and I've got 2 into 5k take away 2. For this one here, I've got 6 into 5k take away 2. And for this one here, I've got 3 into 2 take away 5k. Now note that 2 take away 5k is the same as having negative 1, 5k take away 2. So we can say that this is k over 2 5k take away 2 is 21 over 6 5k take away 2 take away 2k over 3 5k take away 2. So we can see this plus has changed to a minus because I've used this. Now 6 times 5k minus 2 must be a common denominator. So if we put this one over 6 5k take away 2, we need to multiply the top by 3. This one is already over 6 5k take 2, so leave that as 21. And then for this one, bottom's been multiplied by 2, do the same to the top. And now we can ignore the denominators. So 3k is 21 take away 4k. So 7k equals 21, k equals 3. To proceed with this one, I need to factorize the denominator here. Now looking at these other two terms, that gives me a clue as to what that is. Let's just check. 2y plus 3, y take away 2 is going to give me 2y squared, add 3y, take away 4y is minus y, and then take 6. So that's exactly what we wanted. So we've got 3y over 2y plus 3, y take away 2, add 2 over 2y plus 3, take away 2 over y take away 2 equals 0. So common denominator is going to be this. This one's already over that. Then this one, if we're going to put that over the same thing, so 2y plus 3 and y take away 2, that means we need to multiply the top by y minus 2. And then here we've got 2y plus 3, y take 2. So we need to multiply the top by 2y plus 3. And now we can ignore the denominators. So we have 3y, add 2, y take away 2, take away 2, 2y plus 3 equals 0. So if we expand all of that out, we've got 2y take away 4, take away 4y, take away 6. So if we look at the y's, we just end up with a y, and the numbers take away 10, so y must be equal to 10. So let's solve this manually. The first thing I'm going to do is change this slightly. In that I know that 2 minus x is equal to negative 1, x take away 2. So if I make this negative, I can put x minus 2 on the bottom. Now, if I factorize this, I can guess from here that x minus 2 will be a factor. So 2x squared take 7x, add 6. So x take away 2, and then we're going to need 2x to give us the 2x squared here. And take away 3, just check that works, minus 3x minus 4x, so that's all good. So that's x squared, take away 5x plus 4, all over x minus 2, 2x minus 3, and that's going to be equal to negative 2, 2x minus 3, over x minus 2, 2x take 3. Same denominator, so we can ignore. So x squared minus 5x add 4 is negative 4x plus 6. Bring everything over, and we have x squared minus x minus 2 is equal to 0. Now we can factorize that to x minus 2, x plus 1 equals 0, which gives us x equals 2, or x equals negative 1. But note, we can't have this one. This is what this means, because the denominators would be 0 on the original equation if x was equal to 2. So it's not allowed, and this is the only solution. Note that if we solve this on the class pad, this initial condition situation is recognized by the class pad, and we just get x equals negative 1. We're now in a position to do questions 1 to 20 of exercise 1A on page 20 of the 3D book.